Welcome to Samba Samba. Enjoy the video.
You begin by preparing what matters: audio quality and tools. Install Python, a deep learning library, and drivers, then collect labeled commands. Once done, normalize sample rates like 16 kHz, trim silences, and save WAV files with consistent naming. You should define a short intent set now so your dataset stays focused. Make sure to enable a GPU if available for faster experiments. This gets you immediately to a trainable dataset and a reproducible environment. You now transform audio into features, compute MFCC or MEL spectrograms and batch them. Train a compact architecture, say a tiny CNN or lightweight transformer, if you need real-time on-device performance. Once done, apply augmentation like background noise, pitch shift, and time stretch to improve robustness. Make sure to use a validation split and early stopping to avoid overfitting. You'll iterate, adjust learning rate, batch size, and model depth until accuracy and latency meet your targets. You're ready to integrate and deploy. Export the model to ONGs or TF-Lite and embed it in your app or service. Once deployed, test end-to-end latency and lower model size if needed. Make sure to implement confidence thresholds and a hot word to avoid false activations, and secure any remote control paths. If something fails, a key troubleshooting tip: log raw audio and model confidences, reproduce the failing input locally. Then compare preprocessing and feature pipelines to find discrepancies.
Thanks for watching. Consider subscribing if we helped you.